Hey everyone, I am here to give you daily dose of information about Mosfet. Sound interesting, right? Let's get started. So, before we go deeper, first let's take a look at the content. There are 6 content in this video where I will start with introduction to Mosfet followed by types of Mosfet, how does Mosfet works, its characteristics and application of Mosfet, and also comparison of BJT, FET, and Mosfet. As for the introduction, I'll be explaining about what is Mosfet. Mosfet is abbreviated as metal oxide semiconductor field effect transistor. It is mostly used for amplification and switching purpose. Mosfet is a type of FET, which is made by the oxidation of silicon. The conduction of current is either carried out by the movement of electrons or holes. The conduction path between source and drain is normally called as channel. What else? Mosfet is a voltage control device which comes with 3 terminals named as drain, source and gate. The voltage at the gate terminal mostly controls the conductivity between drain and source. Voltage at the gate side is used to control the width of the channel. In Mosfet, gate is practically separated from the entire body by an insulating layer. So, there are 2 types of Mosfet, which is enhancement mode and depletion mode. Both types have P-channel and N-channel. These diagrams represent the symbols of different types of Mosfet for enhancement type and depletion type. If the conductivity between the source and drain increases with the addition of applied voltage at the gate terminal, then Mosfet is said to have an enhancement mode. The enhancement mode is equivalent to normally open switch, and these types of transistors require gate source voltage to switch on the device. Conductivity increases by increasing the oxide layer, which adds the carriers to the channel. These are also termed as off devices. While if the conductivity of the device decreases with the addition of applied voltage at the gate terminals, then Mosfet is said to have a depletion mode. The depletion mode is equivalent to a normally closed switch, and this type of transistors requires gate source voltage to switch off the device. It is also termed as on devices, means they will conduct when applied voltage at the gate is 0. In this circuit, the current flows from the positive terminal to the negative terminal of the battery. Also, the electric flows from the positive terminal to the negative terminal outside the battery. The flow of electrons is opposite to the flow of the electric field. That is, electrons flow from the negative terminal to the positive terminal. The basic structure of Mosfet is shown as in the figure. Here, we observe that the gate terminal is injected into the thin metal oxide insulated layer at the top, and 2 N-type regions are used below the drain and source terminals. In the above Mosfet structure, the channel between drain and source is an N-type which is formed opposite to the P-type substrate. It is easy to bias the Mosfet gate terminal for the polarities of either positive or negative. If there is no bias at the gate terminal, then the Mosfet is generally in non-conducting state, so that these Mosfets are used to make switches and logic gates. Both the depletion enhancement modes of Mosfets are available in N-channel and P-channel. The voltage current characteristics of the depletion mode Mosfet transistor are given as in the figure. This characteristic mainly gives the relationship between drain source voltage and drain current. The small voltage at the gate controls the current flow through the channel. The channel between drain and source acts as a good conductor with 0 bias voltage at gate terminal. The channel width and drain current increases if the gate voltage is positive, and this to channel width and drain current decreases if the gate voltage is negative. While the voltage current characteristics of enhancement mode MOSFET shown gives the relationship between the drain current and the drain source voltage. From the figure, we observe the behavior of an enhancement MOSFET in different regions, such as ohmic, saturation, and cut-off regions. MOSFET transistors are made with different semiconductor materials. These MOSFETs have the ability to operate in both conductive and non-conductive modes, depending on the bias voltage at the input. This ability of MOSFET makes it to use in switching and amplification. The characteristics of MOSFET has three operation regions: cut-off, where cut-off is a region in which the MOSFET will be off as there will not be current flow through it. Second one is ohmic or linear region, where it is a region where the current increases with an increase in the value of voltage. And lastly is saturation region. In saturation region, the MOSFETs have their current constant in spite of an increase in voltage and occurs once the voltage exceeds the value of pinch-off voltage. And as you can see, the table is about the MOSFET type and also the voltage. Applications of MOSFET. MOSFET is used as a switch. It is used to switch the lamp for on and off. It is also used as an amplifier. MOSFET amplifiers are used in radio frequency applications and in sound systems. Lastly, it is used as auto-intensity control of street light. This system is built to overcome the present-day drawbacks of high-intensity discharge HID lamps. Next, as you can see, is the comparison between BJT, FET, and MOSFET. So, as a conclusion, we know that MOSFET requires a voltage and it is ideal for use as electronic switches or as common source amplifiers. And we also get to know about its working principle and application. Thank you and have a nice day.